So our second talk shifts to the world of agentic AI systems. Please welcome on stage Yury from Agent Alpha. He will share hard-won insights today on making LLM-based agents reliable, but also how to reduce hallucinations to design and fallback paths, and yeah, also human escalation, I guess. So please welcome Yury with a broad round of applause.
Hi, everyone. Thanks for coming today, and thank you for the intro, Fabian. Yes, who knows what context engineering is? Can I get a show of hands? Yes, okay, a few. So I want to cover a few topics, as Fabian wonderfully introed, around building agentic systems. I'll talk about what is Agent Alpha. It's the organization that I'm representing today, and a few kind of lessons that we learned along the way, and some good practices that we can use. Who am I? So I've been building AI systems for about 10 years, just over that, starting as a machine learning engineer and touching a bit of all kinds of systems. So in computer vision, in tabular, and also in wind power forecasting, like our previous speakers are hydro forecasting. I was in wind power forecasting. And since about 3 years ago, I dipped my toes into LLMs, starting with ChatGPT wrappers and then more advanced things. Yes, so what do? Right now I'm a freelance developer, AI engineer, and kind of product things. That's me. Okay, what is Agent Alpha? So Agent Alpha is a way for enterprises to manage their knowledge. So it's, think about your RAG application that you commonly think of, but it's actually a lot more than that. So the problem that we're solving is, in a normal company, only 30% of the knowledge is actually kind of written down in some kind of documentation. The rest of it lives in the employees' heads, so that when they retire or leave the company, that knowledge disappears with them. And also, there's these experts in the company that are bottlenecked. If one person really knows everything about their project, then everyone's going to go to them to ask and these questions over and over again, and they're not written down. So these are things that we were hoping to solve and did quite effectively, and I'll show you how that works. And a bit more about concretely how it works. So it can be integrated directly into chat, like MS Teams or Slack, or into some kind of IT ticketing system. And these are the two most common use cases we have. So for example, in universities or in IT support organizations. So imagine you have a chatbot that you ask it a question. Hey, what does this thing mean on my payslip? And then the chatbot can look up information from your company, so it can look up the documents. What does that mean? But we actually go kind of 2 steps forward past that. So if it doesn't find the information that it needs, it can actually find the right person in the company to point you to. And once that person answers your question, it captures that, and the next time you or someone else in the company answers or asks that question, it can actually pull from that knowledge. And so over time, it builds up this company knowledge base. And there were many things that, many problems along the way, and many solutions along the way. And that's kind of what I'm going deeper now into. Okay, let's start from a simple example. So you want to ask a question to your agentic system, and so the basic things of how it'll work. There will be some kind of search, and we need to show the user some kind of results. If there's no results, then we want to contact a human expert. You with me so far? Yeah. Okay, and here's where we get technical. So the naive solution to this is that everything would be its own tool call, or in this case, it could even be the LLM itself. So the LLM can make a tool call for the RAG, and so it can search something up in the database, and whatever gets returned, it can either present it directly to you, or it can, have some kind of function to present this to you. Same with the contacting an expert. It can also choose to do that. And we quickly see that there's problems that arise when the LLM can choose any of these things at any given time, and we ask it to make those choices. What are some things that go wrong? So it can make up information, it can invent non-existing sources, it can hallucinate things. Over time, if you have a really long-running conversation, then it's going to forget things, it's going to forget instructions. If it has 10 tools that it needs to use, then it's not going to follow your strict guidelines. And that's also another topic that I forgot to mention, is the whole EU focus of all this. So we're a Viennese company, and so the sovereignty is a big topic. And okay, quick aside. The first thing that, if you're building an agentic application, the evaluation is very important. So from the very beginning, I really recommend setting up some kind of way to check if your application is performing as you expect it to. And how do we do this? With evals. So more specifically, here's a very pragmatic way to do it with golden pairs. So first of all, you come up with, let's say, 100 at least examples of what do you expect from the system. So you ask a question and you really get everyone to agree, how do you expect the responses to look like? And these really should be yes or no questions, or yes or no expectations, so that you can check, did it use the right tool, yes or no? Did it cite the source, yes or no? And if you have 100 of these yes or no's, then you can get some statistics about how it's performing overall. So that when you make any kind of change in your application, you can track it over time. Okay, let's get into the actual meat of the presentation. I need to speed up a bit. Okay. So overall, context engineering applies to many, many things. I'm only going to talk about a couple techniques here. And of course, it depends on what you're building. But first of all, I recommend first tracking everything that happens in your application and separating those sources, where they come from. So every time the user types something, this goes into one stream. Every time the agent replies, this goes into a different stream. Every time some application, some tool call happens, this goes into somewhere else. And why are we doing this? It's so that we can route it in, we can feed this information in the right time, in the right place, and we can pick and choose from that. So we first need the ability to gather all this information so that we can pick and choose. Instead of the LLM seeing everything at once, we have control over this. This brings me to my next point about the role of the LLM in the application. So we commonly think of the LLM as like the brain of the operation, or the thing that's controlling everything. But I want to push this into a different direction. I want it to be, so in the case of a rally team, we have the driver and we have the co-pilot that gives the instructions. And I think the LLM should be much more like the co-pilot, reading a script, telling the driver what to do. There's a left turn coming up, and the rest of your application is the car and the driver. Or like a telegraph operator. We just want to be plugging in. This is a bit abstract, so I'll get more concrete. All right. LLMs are not very good at doing some kind of abstract thinking, and we really need, so the most powerful models, the ChatGPT, whatever, 5 point, whatever we're at now, or the Opus 4.6, we can actually use a much smaller model if we only get it to do one very specific task, and that's things like data entry. So the rest of the application can actually handle a lot of the things, because we expect one action and we expect a sequence of results that's going to happen most of the time. That is basically the definition of reliability. Everything that we want to happen reliably should actually be done by the application. So imagine going to our previous example. I'm going to skip over a bit. Instead of the LLM choosing all these things, the order in which they should happen and so on, we actually make all of these into an automatic workflow. So as soon as the user enters a query, it kicks off many things that happen in a sequence. Does the search come back with any sources that are relevant? Yes or no? That's logic in the application. Are those sources, and how they're shown to the user and so on. Here's another powerful technique. It's using sub-agents. So if your prompt is way too long, then the agent can get confused, and this leads to hallucinations or forgetting. If you kind of delegate smaller tasks to sub-agents, this works much more effectively and it's way more reliable. For example, we actually inject the prompt to such an extent that when the user clicks a button in the application, we actually feed this data into the LLM. So we say, hey, the user clicked this button. Here's a reminder what you're supposed to do when the user clicks this button. So we inject this kind of like little snippet of the prompt at every step. And this is very effective instead of just listing 100 rules ahead of time that it has to, memorize. Here's how it looks in action. So here the user asks a question, it did a search, and then it shows you can see the results, or you can control the application through the buttons. And the LLM doesn't really have control over this. It's entirely done by the rest of the application. The LLM is only there to feed in the data when we require it to summarize what's going on, to summarize the results and tasks like these. Here's an example of the expert outreach. So the LLM's role was compiling, running a search over the expert, and then once we return the list of the top 10 people, the LLM gets to choose and has to tell us why it chose that person. The rest is handled by the application. And so here we can see, this way it works for every time. So 100% of the time, we're going to choose some expert. So that's the reliability aspect. And it's up to the LLM to choose the best of those people, or to say, there's really no one, but hey, I found this person. Okay, I clicked the wrong button. All right, just a quick summary of all the things that I quickly mentioned. I hope I had to go pretty fast, unfortunately. But evals are very important. Set them up immediately. Rethink what the LLM's role is in the application. It's not there to be the brain. It's there to be kind of like the data entry, the co-pilot, the telegraph operator. Segregate all the things that are happening in the application into different pieces and feed them in at the right time. Workflows for everything that you need to do regularly, hard code it, and sub-agents are quite powerful. As a result, you can use much smaller models. It's so even on-prem, or if you're in your own cloud, you can use a tiny model. It's super effective. We've been using super small models that are much more effective than even the largest ones, just because our harness, like the system around it, works really well. Okay, that was it. Thank you. And if you're interested in Agent Alpha or what I do, please feel free to reach out. I'll hang out for a bit after, before my train comes. So say hi. Thank you.
Thank you very much, Yury. Are there any questions from the audience? Oh, she was fast.
Test. One, two. Yes. Hello. Good evening. Thank you for your presentation. I believe in the beginning you mentioned that only 30% of the knowledge actually being documented. May I ask where did you get this number from?
Good question. It was in some of the research that we did. It's in our Agent Alpha pitch deck. If you want, I can find and send it to you. Yeah. Mm-hmm.
Thank you.
Yeah.
Any other questions from the audience?
So you mentioned that you, or the app will inject certain behavior at a certain time. So let's say when a user presses a button, how does this happen in practice? Is it automatic, or do you manually do it? And if you could provide an example of this in practice, would be great.
What do you mean by automatic or manual?
So you said that when you said so when
Yeah, I can hear you.
Yeah, when the user, let's say, presses a button, the app will learn from that. So learn what answer to give, and then use that as data. So it gives the same answer when the same question is asked. How does it do this? Is it automatic? Is it programmed into the thing, or
Yes, yes.
the user to prompt it to do that?
No, the user doesn't have to do anything. So in this case, if we go through this expert workflow, so let's say you didn't find what you were looking for in the company's database, you reach out to an expert, it connects you to someone here. The expert answers your question. So you click Frage senden, and then it's all complete. You get your answer back, and then you click My question was answered. When you click My question was answered, it kicks off a workflow to like a summarization sub-agent. It takes the original question, it takes the expert's answer and a bunch of other relevant things, and summarizes it into a snippet, saves it into first a regular database, then a vector database, so then it's searchable. Yeah, and all these steps happen as soon as the user clicks kind of case resolved positively. If there's case resolved negatively or like cancel, then it gets thrown away.
Thank you very much. Maybe a small follow-up question on that. I was just curious. So when you feed back this expert information into the vector database, basically, how do you make sure that this information stays accurate over time and doesn't lead to maybe misleading information down the course?
Good question. I mean, it's all new technology, so we haven't had the chance to test it over, many years. But what we do is we capture kind of when it was answered, when the question things, and it's also as part of the search, so we can see how things changed over time. Some of our cases had customers where they have products that get updated very frequently, right? And then the documentation also needs to be updated very frequently. So we had to also put in the metadata of the search, like when was that recorded, or outdated information. And then it can pull through all these sources and it can see, oh, okay, I saw that in our outdated knowledge base, it says you have 30 days of vacation, but we had an expert answer last month that you actually only get 15, and therefore this is the more relevant information that it presents. Yeah.
Thank you very much. So one last round of applause for Yury. Thank you very much.